Hello, it's Alex from Zama. I'm a software engineer here at Zama, and I am working on the Concrete Compiler project. This is a very interesting project that makes it possible to turn existing Python code into an equivalent, fully homomorphic executable. Last week, we have had our new release, and among many new things that came with it, there is a particularly interesting new feature that I'd like to tell you more about today. This new feature is called composition, and what you can do with it that was not possible before is that you can take an output of a circuit execution and use it directly as input to a new execution of the same circuit. This you can do as many times as you want, and most importantly, you don't need to decrypt in between. This is a pretty powerful feature, and as we are going to see, it also allows us to have iterations inside of our code. So I made a small script to show you how it works. We begin by importing the concrete package, and then we define our circuit. Here, our circuit is going to compute the next element of the Fibonacci sequence based on the two previous ones. So the computation itself is super simple, it's just an addition. But we also compute a stopping criterion, that is, if this value is over 100, we should stop iterating, stop computing new elements. We return those two things, and by the way, here you can see another new feature of this release, which is multi-output. So before multi-output, when we wanted to return different things from our circuit, we needed to pack them inside of a tensor. This is not needed anymore, and you can just write it as you would for any other normal Python code. So yeah, that's pretty convenient and pretty useful. We compile our circuit with the composable flag activated, and we proceed with the execution. The first thing that we do is we encrypt the two first elements of the Fibonacci sequence, and we just go with our iteration. Inside of the loop body, there is nothing particularly complicated. We just execute the circuit on the encryption of the two previous elements of the Fibonacci sequence, and this gives us the next element encrypted and the stopping criterion encrypted as well. After that, we just rebind the variables to ensure that at the next iteration, the input of the circuit are the expected two previous values. And basically that's it. That's all there is to the loop body. Everything that's below here is just for printing and demo purpose, but there is nothing more to add to it. For the loop control flow, the only thing that we do is we decrypt the stopping criterion, and based on that, we keep iterating or not. So at a glance, you can see that what composition allows is to have iterations with a fully homomorphic loop body and a clear text iteration control flow. Now let's see what this script does when executed. So yeah, we begin by compiling the function, key set gets generated, then the execution begins. So we can see that the encrypted computation and the clear text computation always give the same results. And as soon as we reach the value that is over 100, the stopping criterion stopped the iteration from going further. So yeah, that's it for composition. I hope that you liked this video. If you need more information about it, you will find other examples inside of the documentation. Thank you very much for watching, and see you next time. Bye.